Okay. All right. Thank you, everybody, for coming today to the Corundum developer meeting for March 14th. And you know what March 14th is? It's Pi Day. Happy Pi Day, everybody. All right. So let's go ahead and get underway. I just have a couple of status updates to talk about here, and then we can open it up for discussion. All right. So let's see, just going over the high level stuff. The initial version of the documentation is done. I just went ahead and got that online last night. So it's up on Read the Docs, and obviously the source is all in the repository, so that can be built locally. It's in both HTML and PDF, and I think also EPUB formats. So anyway, let's see, what else have I finished up? Also the GTY and PLL DRP interfaces, that's done. I've got all the designs updated to use the new wrappers, and 10G25G switching. Basically the hardware support for that is now here, but I need to do, you know, there needs to be some work on the software side to get that all properly integrated. So yeah, everything else is all still basically to do at this point. Haven't had too much time to work on it. Last week was OFC, so I was walking around the convention center here in San Diego instead of, you know, writing code. So, you know, all right. So moving on to this stuff in more detail. So documentation, I got everything set up to use Sphinx for documentation. I pulled in a bunch of stuff from the wiki, and a number of things had to be updated and whatnot that were a little bit out of date. All the register block documentation has been added, and I got a fair amount of documentation for some of the modules. So this is documenting all of the ports and all the parameters. And basically the initial version of that is done. I can go ahead and pull this up here really quick so we can see what it looks like. We got the GitHub repository here. We got the documentation link right up top. This takes you to read the docs. And we have the documentation here. So, you know, the introduction. And if we dig down into, say, the modules, it's got a bunch of the modules, and we got some figures here and there. The figures have been updated with the latest ones as well. So this is the HTML form of the documentation, and you can also get it in a PDF. So if I go to PDF, boink, okay, there we go. Then we have a nice little manual here. 137 pages so far. Only going to get longer probably. But yeah, so we got the contents, and if you go down to, say, modules, it's got the figure. So the figures are in SVG format, and then we use the nice extension put together by the MLE guys to get those converted such that the LaTeX can build this PDF properly. So that all looks pretty good. And I'm not going to argue with that. So hopefully that'll be useful. All right. So the initial version of that is now done. We'll be going through and, you know, adding more documentation for stuff, you know, as kind of on an as needed basis and whatnot. So if I've missed anything that you need, let me know when I can, you know, put it together. And one thing I've mentioned before a couple of times is that there are a few modules that are going to be basically rewritten at some point. So I haven't gone and documented those extensively if I'm going to be, you know, rewriting the modules. So yeah, it's going to be filled out, you know, as things proceed. All right, so let's see, what else do we have here? So VariableDescriptor Support. This is something that I'm going to be getting cracking on relatively soon, at least getting things converted on to use the new descriptor format, even if I don't have the code totally squared away yet for parsing it properly. So talked about this before, so won't spend too much time talking about that. RxQ selection logic. This I think is going to be basically next up for me to get this hammered out. The main thing I need to do here is, well, I guess two things. One, I need to kind of rework how the current RSS module is passing the hash alongside the packet data. What I want to do is move that into basically tuser, and then I'm going to put together a module which performs this you know, computation with the anding and masking and whatnot. and then put together a register block that exposes all of these parameters so you can adjust them. So that's what I'm going to work on this week, and hopefully I'll be able to get that all squared away so that the application section can be used to pick the destination queue. All right, so the management softcore, this is the other thing that that I'm going to be working on. I've done some thinking about this. I think it's going to make sense to integrate the management softcore effectively inside the core modules for Corundum instead of kind of tacking it on in each of the board level designs. So I'm going to work on that hopefully over the next couple of weeks and see if I can get that operational. The one thing that I still haven't totally figured out is how the mailbox protocol is going to work. If anybody has done anything like that or has any ideas on how to implement that, please let me know. Let's see. So not much else to say about that. The PHY status registers. Well, I think what I'm doing for the time being is moving some of the PHY status and control into the management softcore. So I may skip implementing this for the time being. All right, so that brings us to the GTY PLL DRP interfaces. So these are the components that allow the driver and user space software to interface with the transceivers on the FPGA and the reconfiguration interfaces on those. And not only the reconfiguration interfaces, but also some of the other configurable control signals. So using this, you can not only collect some diagnostic information and tune parameters and run iScan, things like that, but you can also change some very low level link settings, polarity inversion, link disabling, PLL selection, things like that. So the BRP interface block that I put together provides a bridge between the register space and the DRP interfaces. And then there's some additional registers that I've implemented in the transceiver wrapper that extend the DRP space based above and beyond what the individual transceiver channels provide. Okay, so the bridge is right. Okay, and then we're gonna have the softcore that's gonna bridge that to the driver. So the driver, instead of poking directly at DRP, is gonna talk to the softcore, which then performs the operations. So, well, I guess when I say done here, I'm specifically talking about just the register block that connects the register space to the DRP interfaces. I don't have the softcore running yet, so this part's not done. The bridge part is not done, but all the designs have been updated to include this this new register block, and I've generated new transceiver wrappers that make the connection, and all the designs have been updated to use those, or at least all of the 10G and 25G designs. The 100G designs don't have the DRP interfaces made available. All right, and then that brings me to the 10G and 25G switching. So this is basically working at this point, at least using user space software to poke at the transceiver registers over DRP. So big thanks to Adam John to help figure out what all of the register settings need to be for switching. So I've taken what Adam John came up with, and I can feed that into the wrapper using the updated using the new DRP interface components, and using that I can dynamically switch between 10 gig and 25 gig. I have not tried switching the PLL or the DFE versus LPM settings yet, but presumably that'll be the same kind of setup. So yeah, this is mostly operational at this point. In terms of what we need from the hardware side, the next step is to implement the softcore firmware, which will simplify this process a little bit. So the idea is that all of the register settings need to be updated. That will just live in softcore firmware, and then you can use a high-level command basically to tell the softcore to load a particular set of registers, a particular set of register settings, and reconfigure the links. to run at 10 gig or 25 gig or whatever. Now, another thing that I'll mention is that I've had a couple different people ask about taking the 100 gig designs and setting those up so they can also run at 10 gig and 25 gig. I've spent a little bit of time thinking about how that would work, but I haven't had time to implement that. So I'm not sure if Adam Dunn or somebody else might be interested in working on that. If so, that's definitely something that that can be explored. Because for that, you basically have to not only reconfigure the transceivers, but you also have to have the effectively a separate data path for the 10 gig 25 gig max, because the 100 gig CMAC doesn't run at 10 gig 25 gig. It only runs 100 gig. So to do the reconfiguration, you not only need to reconfigure the transceivers, but you also need to switch. You need to add some muxes basically to the data path on both sides to switch over. In principle, I don't think it's going to be a huge deal. Once we have the softcore on there, then that'll provide a decent pathway for all the plumbing and whatnot for that to work. All right, and that about rounds out what I have in terms of the status updates here. I'll go put my to-do list for a stable release up again. Let's see, the application section, that's done. Register reorganization is done. The shared interface data path, you have an initial version of that done, but it needs a little bit of polishing. Self-contained checksum offloading. I'm going to punt on that for a little bit. I think since the descriptors and whatnot they have type fields, that's not necessarily the end of the world to skip over that one for the time being. Variable length descriptor support. That's an important one to implement before we can start cutting stable releases, at least in terms of using the new descriptor format on the driver side, because of how that affects some of the queue pointer management. So I'm hoping to get that squared away, within the next month or so, at least, getting the format switched over to the new format. And then we have the on FPGA management softcore. I'm going to be hammering on that over the next, month or so, and we'll see how that goes. So yeah, that's about all I got in terms of status updates. Does anybody have any questions or comments on this stuff? Or questions or comments in general? Ulrich, you want to say something?
I was thinking about it, but I just remembered that we used the OpenAMP framework on Zinc devices to communicate between the R5 and A53 CPUs that uses some mailboxing and interrupts and so on. But I guess that's more for more closely on-die coupled systems. But maybe it's worth a look at it.
OpenM. All right, I'll
OpenAMP, like the amplifier, the amp. OpenAMP.
OpenAMP. Okay. All right, let me
That's also supported by Xilinx for this communication.
Okay. Yeah, I mean, I think the best reference that I have at this point that might be interesting is just how the CMS IP is set up for the Alveo devices, because they have a mailbox protocol over there. So
there is another mailbox protocol for the SDM and the Intel devices.
Okay. I'll take a look at that one as well. I have not looked at the SDM documentation very very extensively at this point.
Yeah, there is quite some pages about this, how you could, for example, write to the flash via the SDM. So there is some read, write, and additional commands. Yeah.
Right. Yeah.
They also document the state machine, actually. That might be interesting.
Well, they have a lot of documentation for that. Are we talking about the configuration user guide, or is there?
That's
I'll
a good
see
question.
if I can hunt that down. If I can't find it, then maybe maybe I'll have to ask for a link.
Yeah, no problem. Yeah, there's a lot of files out there.
Yeah.
Maybe that, but that might be the right one. Oh, I
Well,
guess
it's like
there's
there's lots of
actually,
references to it, but finding just a single comprehensive manual is
yeah, there is a separate IP core for this. There is a mailbox IP core. I know I looked at it, but some documents are named in a way that you can kind of guess what's in there, but some are just numbers. So.
yeah, go figure.
That's one that could.
So I found the Stratix 10 configuration user guide. I don't know if this contains much about the SDM. Might contain some documentation about that. JTAG and active serial. Yeah. Well, maybe this is something to work on offline. If you have a link to that documentation, that would be nice, so I can pull that up and take a look at it. Or for the,
Okay.
you said there might be a separate document for the IP core.
Yes, I think I just got it. Yeah, I just share the link. Guess
Yeah,
that's
okay,
the
that would be
one
cool.
I was referring to. Yeah.
Perhaps another route which could be taken in terms of research is going from the software perspective. So how the driver or software would talk to this little CPU. And I guess the keyword here for Linux is the remote processor framework.
Okay.
Which is, I think, employed by such things as OpenAMP, together with the so-called remote processor messaging framework.
Right. Yeah, I mean, I don't know if we need like a whole framework for this, but at least, coming up with a decent communication scheme is probably going to be pretty useful.
Yeah, to be honest, I didn't look into that or did nothing with it so far, but I thought it might make sense here to look at it.
Yeah, okay. I found a link to that. So an ST page that's talking about the Linux remote proc framework. So I guess I'll take a look at that a little bit later. Yeah, okay. Well, there's a few things to look at then. We got the mailbox IP for, okay, this is the mailbox client IP, and this is specifically for the SDM. Yeah, okay. All right. Well, got a couple of things to take a look at then. Cool. All right, so what else do we need to discuss? Are there any updates from the MLE side in terms of Zinc device support and the DPTK driver and whatnot, or?
Yeah, so DPDK device driver has been cleaned up. There is something weird going on, which we are currently following up on, but I guess that'll be quickly revealed. And then we issued a pull request with respect to the optimizations for Intel devices.
Right. Okay. Yeah, I saw that. I haven't had a chance to take a
something.
look at, or I haven't had a chance to take a super close look at that.
Yeah, no problem.
Just trying to get my head wrapped around exactly what needs to be changed in terms of those RAMs and whatnot. Well, what's the story with the Intel end on that? I know you guys have some communication with their support people.
Yeah, so I've been,
what exactly they're you're trying to get adjusted?
Yeah, so there is two issues we're talking about with Intel. One is that it seems as if some, how should I put it? So some fixes are not propagated across all instances, which is very weird. And the other one is that there is a compiler issue somewhere, and we are just investigating when this could be, or if it's actually already in progress to be fixed, or if this is if it is already fixed in a future version. So there is some internal operations that Intel are following this up on, and yeah, we are also checking this if these workarounds for now are breaking something else, or if it's still compiling fine. I guess it turns out it will be compiling fine, we think. But on the other side, so I haven't been in contact with Intel for the last 2 weeks because I was out of office all the days we usually do our discussions. So I guess mid of this week I get an update on this one.
Okay.
But other than that, so these pull requests we provided that should at least enhance some of the BRAMs and relax the timing on the Intel devices as well.
Right. Okay.
Even though it's not fully fixed yet.
Right. Actually, I'm just thinking one thing that I should do is just go ahead and pull those into a test repository and see if I can build the 520N MX design and just see if that works or if it's still failing. Just to see if it's fixed though the paths that were problematic for that one. So I should probably do that sooner rather than later.
Yeah, just do this. I guess we did a build for the ZCU 106,
right,
and tested it.
Right.
But,
yeah. So you mainly just did some tests to make sure that it hasn't broken anything on the existing designs. But yeah, building it on the Intel designs to see if it's actually helped is definitely something to try. So, well, I guess you've done some test builds on your on the Stratix 10 GX, right? That you guys are going to be using. So.
Right, we did test builds for our target design, and we also did test builds for the Stratix 10 GX dev kit, but I haven't been able to run those yet. So there is something else
if it fails timing horribly, then what's the point?
Yeah, well, I thought it would be okay because it just fails timing on one corner. But yeah, once I loaded it, things happened on the PC and it at some time crashed. So I have to look at it again. But
before you loaded the driver, it crashed?
No, once I loaded the driver. So it could be something happening on the interaction side, maybe related to timing, not sure.
All right.
So let's see. Yeah, and I guess this right. So that's where we are on this page. There was another thing I want to discuss. Now we are currently integrating our internal functionality, and we are thinking about how we could expose this to the driver to maintain cross compatibility, right? So that you could use the upstream and QNIC driver with this device and it would work just fine. And the other way around, we could use our enhanced or modified driver to work just fine with a regular MQNIC. And I guess there is something missing in the API to make this seamlessly happen. And Joachim and I were scratching our heads today a bit about how we could do this, because I guess there is a firmware ID, which is fine, and we do change this, so that makes sense. But there is also there's also device IDs we could use, but if we want to make it both ways compatible, then we kind of need to maintain the the compatibility mode to upstream, right? So this is the versions of the blocks, for example, that describe the register API.
Mhm.
But if some additional things have been added and this changes or might change behavior, then we might need to some way to flag this to the driver. So I don't know, maybe say something. Custom extensions are available. Look here.
Right. Yeah.
So
So I guess one thing you can look at is the presence of the application bar, right? Because if you don't have that, then there's none of the application stuff.
yeah. So the thing is, it's not part of the application what we did. So maybe
okay.
we have to change this. I guess in one place we could definitely move this into application, at least once your changes for queue steering are in place.
Right. Yeah.
But maybe there is additional items that we need to kind of, or where we need to maintain a diff in, and then I don't know. So we didn't come up with a real concept there, but one idea was, if there is a feature register, and maybe add a bit that just says, okay, there's an additional custom feature register, and so this is only valid when this custom feature present bit is set, and then you can have like a correlation from, I don't know, firmware ID or PCI Express device ID to custom features, and then cross correlate. And the original behavior is not touched by this because the upstream MQNIC driver doesn't use this.
Right. Yeah.
And we need obviously we need to make sure that in RTL we also don't do something different. So behavior must be the same then. But I guess for now we can do this, and we don't see something blocking this in the future as well.
Yeah.
So I
That's
don't know.
certainly something interesting to think about. Yeah, not sure the best way to go about doing that, but yeah, definitely makes sense to bounce some ideas around there. I'm not sure what would make the most sense. I mean, we can certainly add more feature bits or feature registers or whatever, but I mean, we can always add more register blocks too, right? I mean, you can always add one that's specific to your functionality, and then if it's present, then it's present. If it's absent, then
Yeah, that sounds like the generic solution. I guess our thoughts were more in the area of, well, we added even a little thing, a little feature, a little something which is just a modification, where one could argue, well, adding a whole register space for that, we don't know if that's needed. And then the thought was, well, there are certain blocks at least have a feature register and bits. And this is where the idea came. Well, if Corundum as the upstream project would define a certain feature bit as saying, as Ulrich said, yeah, custom features here, and this would mean something to the custom driver, but will not break the upstream driver. So yeah, I mean, in the end, for big changes, I guess adding a register block is the way to go.
Yeah, I mean, I was just thinking, if you add some custom bit of functionality, presumably you'd have to configure it somehow, right? So how are you configuring the functionality that you've added now? Did you add some registers somewhere, or?
Yeah, that's another case. You're right, where most likely a separate register block makes sense. But in this case, it's a very simple one. It's basically enhancing the hashing module, the RX hashing module, where simply the software in the end needs to know, is this feature there or not?
Right.
And in this case, well, yeah, of course, a register block will will do it. Seems like a bit oversized, overkill solution for just saying, yes, I'm there.
All right, well, we can discuss that. And I guess depends on what your improvement is. I mean, maybe it should just be, upstreamed.
Yeah,
and
of
then this wouldn't be a
course,
problem.
sure.
That's always a possibility as well. Maybe depending on what it is. If it's something pretty narrow, then actually, so one thing that I have been planning on adding at some point, but haven't done this yet, is bringing out basically an application section ID effectively into the top level register block. And then this can be used for attaching the extension device drivers. So it'd be similar to the firmware ID, but it would be set from the application section. So depending on what application section you have, I'm thinking the way to do that is to have like a port that comes out of the application section that will then drive the that particular register. But then that will be used when attaching to extension devices and things like that. So I haven't gotten all the details for that fleshed out yet, but that'll be another thing that we'll have available at some point for identifying customized functionality integrated into the design. All right. So what about Zinc device support? I know you guys got that working a while ago, but is that in a state where that can be merged back in, or does that need to be updated, cleaned up, etc.?
Yeah, unfortunately, still needs half a day of work, I would say. It's still on our to-do list, and we will do it in the end.
Okay. Well, so it's working, but it just needs some cleanup, or?
No, basically needs rebasing on top of current changes, which are quite some changes.
Right. Okay. Gotcha. All right. Yeah, because we're starting to do some work with the Zinc SOMs on our end, and it would be nice at least to have the build system figured out. So I guess we can look at your slightly
Certainly,
old pull request and see how that's done from there.
Yeah. Well, I guess nothing will change there. It's really just rebasing the driver, basically adding the platform driver in terms of the new infrastructure you have in the main.c.
Okay. Right. Yeah.
Figuring out all the where has to go what and which function calls which and so on.
Right. Yeah. I think mainly those changes have been more kind of organizational. So I peeled apart the PCI Express specific probing from the kind of core design probing. So that shouldn't really be that should almost make your job a little bit easier, because you just need to do the platform specific stuff and then to call into the common probe.
Unfortunately, we kind of did that already in our previous patches. And now it might be a little bit different. Unfortunately, I didn't have a look at it so far.
Okay.
But
yeah,
it should not be much.
I know the other thing that I changed is how the interrupts were handled. So previously I had a rather stupid implementation, and now I found the atomic notifier change, so I'm using that now. But yeah, so I have a new IRQ file which handles the interrupt notifier chains and a couple of other things associated with that. So it's set up for PCI Express, and I guess we'd probably need to add another init for whatever you need to do for the platform device driver. So in principle, not really a big deal, but requires a couple lines of code for that. So anyway, Yeah, so I guess probably the important part from our end is to just figure out what the build process is for working with Peta Linux and whatnot.
Mhm.
And Spencer Chang is on the call here, and he's been working on the board design for the SOM carrier board that we put together, and he'll be working on the software running on there. So both of us have to get up to speed with how to build that.
Yeah, I think this won't change, so that
Yeah.
part should be rather up to date.
Right. It looked like you guys
And,
had some pretty extensive build scripts for Peta Linux that you put together. So,
well, extensive. I mean, that's what we use for our Peta Linux projects. It's
right. Yeah.
basically as yeah, extensive. I wouldn't call it extensive.
All right. Fair enough.
Perhaps hard to read since it is written in Make. But it's basically a wrapper around the Peta Linux tools. So to even more put it more simply, a wrapper around the most important steps for building Peta Linux.
Gotcha. Okay. I know there was also some talk about possibly using Ubuntu instead of Peta Linux, right? So I guess the trick with that is you just kind of install what the ARM version of Ubuntu effectively, and then you somehow have to integrate the updated device tree and potentially a custom driver or custom kernel in with that.
Yeah, it's definitely an alternative. Yeah, but the point is where I think Peta Linux is still good for here.
Right.
I mean, it's a small system. It's kind of in a box, no other dependencies, no fetching huge something packages. It just builds a minimal system for driving the thing, showing off the thing, without much dependencies, besides Peta Linux itself, of course.
Right. Okay. All right.
Self-contained was the word I was searching for. Self-contained.
Right. Okay. All right. Well, we'll take a look at that then. If we have any questions, we know where to ask. So.
Yeah, sure. Yeah.
All right. Anybody else have any questions? Is there anything else we need to discuss on the MLE side of things at this point? I think we've covered most of it.
Yeah, one thing I guess, Ulrich, we wanted to talk about that, or at least mention that last time. We had a discussion about performance, and in this area, you came up with the page pool API of the kernel. And I guess you mentioned that somebody, I forgot the name, might have done something
Ray,
here.
I think, yeah, he mentioned something, I think, at one of the previous developer meetings, but haven't seen him in a while. So,
okay, so that's a while back. Mm-hmm.
Yeah.
Yeah, and I guess I wanted to ping him personally in Slack, and I just forgot to do this actually.
Well, it happens. All right.
So just to make sure, there's no official pull request or anything like that.
Yeah, he hasn't opened one. So, if he had opened one, I would have forwarded it to you guys. So, yeah, I actually did take a look at the page pool myself quite some time ago. But I guess it wasn't clear how much that would help. But I guess he implemented it and it does help. So, okay.
Okay.
I guess there's like a couple different aspects to that. Right. I guess the other thing I was looking at is not so much just the page pool, but using pages multiple times. So if you're using like an MTU of less than 2K, then with a 4K page, you can actually put 2 packets in there. So this is something that some of the drivers do, and I know at least, was it the Intel drivers that do that, or the Mellanox drivers? A couple of the drivers I look at, they basically they use the pages twice, and then they keep them recycling. So they do some screwing around with the page reference counts and some other stuff. Unfortunately, I'm not very familiar with the Linux kernel memory management subsystem and how the page reference counts and whatnot works. So I'm like, if I try to do this, this is going to break horribly because I have no idea what I'm doing here. So I haven't bothered implementing it because it's like, yeah, I'll leave that to an expert that actually knows how this stuff works. So I can certainly try to hunt down some of those implementations and send you, some links to what I've discovered, and then you guys can take a look at it. Since I think you know a little bit more than me about how the memory management subsystem works.
Oh,
But
well,
yeah.
maybe.
Maybe. Maybe we're all in the same boat. Who really knows how it works, right? Oh man. Okay. Well, what's the MTU size that you guys are working with? 1,500 or less, or are you working with larger packets?
At the moment, it's kind of a little bit more than that.
A little bit more than that.
Yeah.
Well, more than 2K?
No.
No. Okay. So between
So
1,500 and 2K. All right. Yeah. I mean, if it's more than 2K, then the best you can do is pages. But if it's less than 2K, then you might be able to do 2 on one page. And that, I guess there's two things that you want to reduce, right? One of them is you want to reduce how many pages you're allocating in the first place. And then the second one is if you can, use those pages twice, then you're just using fewer pages, basically. So it's possible that, trying to use each page twice doesn't really help all that much versus just trying to avoid handing the pages back to the kernel all the time. So I guess that's part of what I don't really have my head fully wrapped around, is that they were doing some screwing around with the page reference count so they can return the page to the kernel without actually freeing the page. And then once the kernel is done with it on its end, then it can reuse the page. But it was a little bit unclear to me exactly how that part of it worked. So I'm not sure if the page pool API helps out with that, because from my reading, it seemed to be the page pool API was more about XDP, and because XDP will basically free up the pages internally because it will, turn them around and send them back on the same interface or whatever. So with the page pool, you can kind of get a pool of memory pages for receive, and then as XDP finishes with those pages, they can go back into the pool. And all that seems to happen kind of within, at least from my understanding, kind of at the same time. It's not like the pages get handed off to some other entity that goes and does something for a while, and then eventually the page will become available again. So I don't know, something that we probably need to do some more poking around on. I'm not sure if we have anybody else that knows more about Linux kernel memory management and page pools and whatnot, but I guess the other concern was when page pool was introduced, and I think it's old enough that your CentOS target should support it, but I'm not sure. We might need to double check on that.
Yeah, always.
Yeah, nothing is a given in with those old kernel versions that lie about what features they support. Oh, but speaking of feature support like that, I think Alex Bedea posted something just yesterday or whatnot, that there are some defines for when you're running under Ubuntu to figure out what the ABI version is. So yeah, I guess now you have normal Linux kernels that have not been modified. You've got the Red Hat CentOS ones with the Red Hat release you got to look at, and then with Ubuntu, you got the Ubuntu ABI version that you got to look at. I don't know if you saw that.
I saw it. I didn't read it so far. So most likely I guess they have a similar mechanism to what Red Hat does.
Yeah, I guess so. It seems to be more limited, more narrow. Hopefully we don't bump into any of those APIs because that's just like really.
Yeah, well, as I said last time, I already hit one. So.
Oh, you did? Well, that's annoying. All right. Well, I guess we might need to take a look at those defines then around that particular API. Was this in the Corundum device driver or something else?
if I could remember, I don't remember what it
Oh.
was. It was no, it was in the area of IP protocol handling something.
Ah, I see. Okay.
Perhaps it will come back.
Okay. So something you might need to poke at for your
No,
customized-
not really at this point. I mean, CentOS 8 is a requirement. So it's not Ubuntu. So that's
Well, no, I
just
mean
a
that
side note so far.
API.
Come again?
No, I mean that API is something that we don't necessarily need for Corundum, but that API is something that
Yeah.
we're using
It
for the
was
customization.
yeah. Our customizations, yes. Mhm.
Right. Okay. Yeah, because that's one thing that I've been trying to do. One of the motivations for getting the softcore in here is to remove all the dependencies on the Linux I2C subsystem, which changes
Mm.
periodically, and I got a bunch of if defs for that. So yeah, if we don't use it, then I don't need all those if defs. We can get rid of all that. Makes things simpler.
Yeah.
All right. Well, let's see. Anything else to discuss here? I know Adam John doesn't have a microphone today, it seems. I did mention that that 100G switching down to 10 gig and 25 gig. I know you guys are working on that that 40 gig Mac, so that could potentially be, you could, if we get that that Mac integrated as well, then you could do 100 gig, 40 gig, 10 gig, 25 gig switching. I'm not sure if that sounds like something you guys would be interested in working on or not, but that is an option. That is something we could do. No comment on that. All right.
Well, we use the 40, 50G Ethernet subsystem from Xilinx in a different project, but it's not this project now.
Right.
So we do use it, but yeah, so we can, and it's very similar to the 100G subsystem, I would say.
Right. I mean, I guess the tricky part is that if you want to do the runtime switching, you kind of have to peel things apart and handle the transceivers separately. So that complicates things a little bit. No, but the folks at what was the name of your guys' company? Boss? Is that what it was? Well, Adam John was telling me that I guess Egla has been working on putting together a soft 40 gig Mac. So figured I would throw that out there because that might be a potential use case for that is, you know, in Corundum if people want to run it at 40 gig. So, because I know the nice thing about the 100 gig subsystem is that it uses the hard logic, and as a result, the license for it is no charge. And for the 10 gig stuff, you know, I have my own Mac for that because they charge an arm and a leg for the 10 gig Mac. I guess the PCS PMA is free, but you know, I also have my own logic there because we've been doing this. That's potentially useful for some of the circuit switching stuff if we need to make some modifications to speed up the link up time. You know, if we have our own PHY core, we could do that. But yeah, so the only hole is at 40 gig. I haven't had a need for that, but if these guys are working on a 40 gig Mac and PCS PMA, then we can potentially look at integrating that. So
I guess
anyway,
more interesting would possibly be the 50G path.
The 50G
because
path.
because that's half the transceiver amount, right? So I guess that's what data center will be doing next.
Well, yeah, I don't know. I just came back from OFC and they got some pretty crazy stuff. So
yeah, okay. But that's the crazy stuff, and there is the other stuff that that people buy in thousands of units.
Right. Yeah, that's true. Yeah. So I guess 50 gig, that's certainly an option. I guess part of the issue is when you start getting to these higher line rates, then you start running into RSFEC and things like that. So and that complicates things when you're, you know, trying to bring up one of these interfaces, is that you'd have to implement both the encoding and the decoding. and that can take up a lot of logic.
Yeah, but actually, so the interesting part of 40G, 50G is that both rely on either the 10G or 25G sublayers. So that's kind of a wrapper around these PCS layers. It's just distributing data on multiple 10G or 25G lanes.
I mean, and 100G is also like that, right?
Right. Exactly. Yeah, that's right. Yeah. Obviously, that's the same.
Right. Yeah. So when you get,
but
into
it kind of
25 gig,
costs half the thing. If you do 50G, it kind of costs half what 100G is costing, because the transceiver is the expensive part.
right? And yeah, both in dollars and in power. Yeah.
Right. That's why
pins and board
25G
area
was
and-
so
yeah.
so good, so exploding in the data center. The adoption was pretty fast because it's the same amount of ports, the same amount of transceivers. You just go from 10G to 25G, and that was an easy way to do this.
Yep. And now we're bumping up now with PAM4. You can do, well, like Adam John just posted in the chat, 100 gig on a single lane. So that's 56 gigabaud PAM4. And then I guess at OFC, Intel just had a demo of 112 gigabaud PAM4, which is 200 gig on one pair.
Yes.
I just wonder how far you can send that over a board. Probably not that far.
Yeah, it depends on the material of the board, right? It's probably not FR4 anymore.
I don't think so. Or at least it's a a refinement of FR4 that's more uniform, because at those high frequencies, and it's the weave that's causing half of the problems.
Yeah, exactly.
All right. Well, is there anything else to discuss here, or I guess if nobody else has anything they want to bring up, anything they want to ask about, then maybe we'll close down the meeting for today. And happy Pi Day, everyone, once again.
Thanks, and you too.
Just out of curiosity, the bug you detected when receiving a very short packet.
Oh yeah, what about that?
Did you follow up on that, or have more to say to that? I mean, I posted my thoughts or my tracing down the code.
Right. I mean, it seems to be a Linux kernel issue. I mean, I would assume that somebody should add check in there somewhere, so that if that happens, I mean, printing a message is good, but crashing the entire kernel due to a null pointer dereference is not so good. So I'm assuming that should probably be reported to somebody and fixed, but I don't know what the process is for doing that. I mean,
yeah, at the first look, I also thought, well, that seems to be a clear bug. On the other hand, then this commit message, which I posted in Slack, which says, however, such a condition is really indicative of a broken driver.
Right. Yeah.
That kind of, then I thought, well, so drivers should drop short packages before entering into the kernel.
I guess it wasn't, from all the drivers I've looked at, I don't think I've seen code that specifically drops packets that are shorter than a certain length. And it seems one of the calls that leads up to this issue is checking the length and dropping the packet if it's too short. So, I mean, yeah, I guess if the driver is working properly and the NIC is working properly, you shouldn't see packets that are that short. But I mean, I guess.
Yeah, I wonder, because
is, whose responsibility is it to drop a short frame?
Yeah,
I guess ostensibly it'd be like the receive MAC. If it's too short, you should drop it. But if the receive MAC doesn't drop it, and it hands it off to the driver for receive, I mean, is the driver supposed to drop it then? I mean, I don't know.
I guess that's worth a question on the Linux kernel networking.
Yeah, sure.
Something mailing list.
Yeah, most probably. I'm not sure what mailing list would make sense. If you want to ask about that, that would be cool. If you can point me to where to ask about that, then I guess I could make a post. I mean, I don't know. Now that I figured out
okay.
what caused the problem in the first place, then it's not as big of a deal. So the thing that caused the problem is that I screwed up the register updates to the transceivers, that I had the clock divider set wrong, and as a result, it was the PHY was basically getting a bunch of crap, and yeah, somehow was interpreting that as very short frames. So anyway, it's fixed now. Once I figured out that it was actually what I'd messed up is a couple of the defines that I added. I mixed up the value 1 versus 0, so it was running at half rate when it's supposed to be running at full rate, or the other way around. Can't remember exactly what the deal was, but yeah. So that after fixing that, I haven't run into that issue again. So anyway, it would probably make sense to get that at least looked at upstream, because I guess things have. It seems like at some point they added that print, probably because there was a broken driver. And somebody was annoyed about that. But
yeah, at least that
then things have evolved, and they haven't had another broken driver, so nobody's noticed the same fault that they introduced.
Looks like it, yes. One other quick question.
Sure.
Did anybody run the MQNIC driver together with VLAN?
I think Garay might have been doing a little bit with that. He was running into issues with everything ending up on Q0. I'm like, I'm not sure why that's going on, but he didn't say anything about the data he was receiving or anything like that. And I think it eventually came up that that there were VLAN tags, and the RSS code was interpreting those as not IP packets, basically, and then not computing the RSS hash, and then everything ended up on Q0. But yeah, in principle, there should be no problem with running, VLAN tag traffic through Corundum. It's just the main issue is the RSS is not going to handle those correctly in its current form. Eventually, I need to. So what I want to do is write a better IP header parser, basically, that can be used both for RSS and also for the checksum offloading. I haven't had time to do that yet. So, and when I do that, I want to make it handle at least one, hopefully 2 VLAN tags. So are you guys using VLAN tags for your setup?
No, that was just a side question which came up while looking through code or searching for a specific functionality which has nothing to do with VLANs. But then I wondered why the MQNIC driver is not calling the what's the function, the ETH type trans function before handing off the SKBs to the kernel. And
so I think it might have been calling that at one point. But I think I removed that because I was looking at some other drivers that didn't call it. I would have to go look at the commit history.
Okay, then I'll look myself. I wondered about that.
If it needs to be called, then let's add it back.
Yeah, I mean, I just had a very quick look and did a grab over the kernel, and it seems like kind of every driver calls it, but I didn't check if it was really every driver.
Right, yeah. No, I distinctly remember putting that in at some point.
Okay.
But it's possible I removed it at some point. I just can't remember why off the top of my head.
Okay,
I'll have a look. It must
look.
have been after either looking at some other driver or looking at some documentation, and it there may have been some indication that this isn't necessary or something.
Yeah,
things
in the
change,
end, it
so-
has to be done. In the end, it has to be done. Otherwise, I don't know how the protocol demultiplexing is then working, because it needs to have a valid protocol.
All right. Well,
that's a function which determines that.
I guess I need to get blame and look at at what I
Yeah, but
removed and
we
when.
don't have to do that now. It's just a quick question which came
Yeah,
to
no,
my
that's
mind.
a good point. I can't remember why I removed that. I'm pretty sure I removed that at some point, but yeah. All right, I'll take a look at that and get back to you guys on Slack then.
Yeah.
Let you know what the story is with that. All right. Does anybody else have any questions or comments or concerns or musings or anything?
Hey, one quick thing. Were you talking about runt packets? I didn't hear the whole conversation.
Right. So yeah, essentially, so this is something that happened while I was testing out the 10G 25D switching, and I'd screwed up something in how the registers were configured in the serializers, and as a result, the link wasn't working. But it wasn't just not working; it was generating a whole lot of 1 byte long frames for some reason on the receive side. And the Mac that I have, it doesn't do any checking on the minimum length frames, just, you know, passes everything through if it's got something. It's a relatively simplified Mac. So basically that was getting passed all the way back down to the driver, and the driver was handing off these 1 byte frames to the operating system.
Wow.
And it was seg faulting. I'm like, what? why am I getting a seg fault? And it seems to be just a kernel bug that was introduced somewhere. So they have a check. If the packet is shorter than a certain length, then it drops the packet. But when it drops the packet, it sets the return value of this call to null, and then the calling function just dereferences that value and uses it and crashes. So they need to add a null check there. But the silly thing is the function that drops the packet also prints a message saying that it received an impossible SKB that was too short, which, you know, makes sense. They're complaining about the driver having a bug in it. But, you know, complaining is one thing. Going and complaining with a seg fault is is a problem. Well, I guess it's not really a seg fault in the kernel, right? It's a null pointer dereference. So I guess that's a slightly different deal. But yeah, so I'm thinking we should probably report that upstream to say, hey, you guys need a check here just to make sure, you know, the kernel doesn't crash when this happens. Even though, yes, I guess this is technically the result of, you know, a hardware problem or a driver problem.
I'll have to check. I think some of our NICs do just drop it and peg a counter. Right.
Yeah.
That's the standard. And
yeah. I mean,
I know our switches, most of our switches typically do. When they see runt packets, they just peg a counter. You got a runt on this interface, and then that's it. But I'm not sure about all our NICs. Some of them may drop it and just peg a drop count, because I don't think there's a runt count.
Right.
And normally you want to know the difference.
Right. I mean, what might make sense to keep track of is not so much just dropped packets, but like FIFO overruns, right? So if you're dropping a packet due to a packet being invalid versus dropping a packet due to not having FIFO space to store it, that definitely makes sense. But yeah, in terms of recording exactly what was wrong with the packet, in terms of the you know, recording errors, I guess that's potentially a little bit less important.
Sure.
I don't know. That's something I need to add at some point, is counters for this sort of thing. A while ago I added kind of a subsystem for collecting all of this type of statistical information, all of these counters, but I haven't yet connected that to the Mac components and some of the other stuff. It's actually hooked up to PCIe for now, so you can record how many TLPs were sent, received, and whatnot. So
Oh, that's pretty nice.
yeah. So that's I'm planning on wiring that up to a whole bunch of stuff internally. So you can see the numbers of descriptors that have been sent and received, and the number of packets that have been sent and received, you know, all sorts of stuff. And it's also available to the application section. So the application section can send statistics as well into the same pot, because they get integrated into a basically a big block RAM. So it's relatively efficient in terms of FPGA resources. So
are those are some of those integrated with the driver for IO Octal and East Tool?
Not
yet,
yet.
or-
That's
Oh,
what I was
they're gonna
getting
be,
at. Is the main thing I need to do now is like the subsystem is there, but I don't have it brought out to software yet. So part of the problem with that is, you know, you need to label all the counters. So I got to kind of figure out the best approach for that. And storing a block RAM, you know, for just the counters, it's not such a big deal in the FPGA configuration, but storing all of those strings in the hardware wouldn't work very well. So I got to come up with a decent solution for recreating those somehow on the driver end. So that's on my to-do list, but it hasn't been a particularly high priority. So at some point that will be operational, and then yeah, I'll make those available through ETHTool and potentially through other APIs as well. I guess ETHTool kind of has a just generic set of counters that you can read from, something like that. So
Yeah.
Right.
like it doesn't really care too much about what they are. But
Right.
you can just have a huge list of all sorts of stuff.
You can, yeah, I think you can have custom ones as well as there's a standard set as well, right?
Right, yeah.
Yeah,
Yeah, I
but
guess right
ETHTool,
now
there's only
but
the
there's also-
custom ones.
That leads me to configuration, right? Because some of them are configurable, like, you know, things like interrupt coalescing, size of rings, TX, RX rings, and things like that. And even filters, right? You can put in tuple filters, like hashes. You know, how much of that support do you have fleshed out, or is that something work in progress still? I'm sure, right?
Yeah, I mean, I think it's basically the stuff that the hardware supports. I've tried to get that connected up to ETHTool, but yeah, for most of it is not supported right now. So I mean, yeah, ETHTool can do all sorts of crazy stuff because Nix
Yeah.
can do all sorts of crazy stuff. So yeah, at some point, definitely some of that has to be fleshed out a little bit better. I mean, even for like RSS right now, it's like with RSS, usually there's a kind of an indirection table that's used to map some number of LSBs, I guess, of the flow hash onto queues. So you can, I guess that's kind of a sort of an accelerated version of a modulo operation, more or less. So depending on how many queues you want, you can, you know, evenly spread the packets across those queues. So I don't have an implementation of that. I just have a bit mask. So that doesn't really match exactly what the ETHTool API does. But it looks like from my poking around that might be the Mellanox NICs basically do the same thing. So they kind of fake out the indirection table and they'll only accept tables that they can convert into a bit mask. So I think I actually have some code somewhere that does more or less the same thing that I haven't committed yet because I haven't had a chance to get it all, you know, get all the kinks worked out of it and whatnot. But anyway, I'm going to be overhauling some of the control registers for RSS and whatnot. So once I get that done, then maybe I can look at pulling some of this code back in so you can change the number of receive queues. There's a lot of little loose ends of that nature that I need to deal with at some point. But I mean, the way I develop this stuff is just what we need for the research project and whatnot I work on. If it's something I can, you know, kick the can on for a while, then, you know, I put it on the back burner. So the hope is that if we have, you know, a good group of people in the community and somebody else needs a particular piece of functionality, then they can work on it and I can give some pointers and then we can get it all integrated. So I guess we'll see how that works out going forward. So, but I guess the other thing is that if you're doing customized packet processing on the FPGA, maybe you don't need some of these features if you're just going to be doing something custom yourself. So I don't know.
Yeah, yeah.
More dependent on what people are doing with it. So
The use case here, a lot of times though, they want to see it both. So you send the packet back to the host and then you also process it. So you can
Right.
kind of monitor your app on the FPGA.
right. Yeah, but I would assume that the low latency, financial use case is probably rather different from a lot of the data center stuff. So
Typically, yes, yeah.
all right. Well, does anybody else have any questions or comments or anything, or shall we close it down for today? All right, well, going once, going twice. Nope, Ali?
Yes. Hi everyone. This is my first meeting. Actually, I was trying to learn about the Linux driver part. Is someone responsible for this?
The Linux driver part, just drivers in general, or the Corundum driver specifically?
Kernel drivers specifically.
You mean kernel drivers in general?
No,
Or
the
Corundum
Corundum
device
part.
driver. Oh, okay.
Yes, Corundum device driver.
Well, I wrote most of it, so I'm probably the best one to ask in terms of the kernel driver, but I will say that I'm not an expert on Linux kernel development. We have a few people on here that know a lot more about that than I do. So if you have a specific question, I mean, go ahead and ask, or you're just listening in.
Actually, I was thinking of contributing to Linux device driver of Corundum. So
Okay.
If there's someone responsible, I can communicate with him or her too.
Well, I mean, I'm basically the maintainer of everything right now, so I'm probably the person you want to talk to.
Okay, then I'll write to you after the meeting.
Yeah, sure. I mean, you can just post on the Slack workspace we have set up. Are you a member of that?
Yes, I know the Slack of the Corundum.
Right. Okay. All right. Yeah, you can contact me on there or just post. I think we have we should have a channel for drivers, so you can just go in there, and I think all of the relevant people should be in there. So.
Okay. Thank you.
Was there a particular aspect of the driver that you were interested in working on?
Actually, I am interested on financial part and also communication part. So I think that I can contribute to Linux drivers while making it high performance.
Well, high performance in terms of throughput, in terms of latency, in terms of
both latency and throughput, actually.
both latency and throughput. Well, improving the performance is always useful. Do you have any hardware that you can test with?
Yes, we have hardware.
Okay, so you have an FPGA that you can run the design on, but you want to work on the driver. Okay.
Mm-hmm.
Nice. Well, yeah, contact me on Slack and I'll be happy to make sure you got everything all set up so you can help out with stuff. We definitely need to do some work on the receive side in terms of memory management and whatnot. We were actually talking about that earlier. I'm not sure what time you joined. I guess we did have a daylight savings time change in the US, so it's I don't fault you if you got the time wrong.
Okay.
Yeah. All right. Well, does anybody else have any questions or comments or anything? Going once? Going twice? All right. Well, I'm going to go ahead and close down the meeting for today. Thank you all for attending. Happy Pi Day. And yeah, signing off for now. see you guys in 2 weeks.
See you. Bye bye.
See ya.
Bye.